This is question 8 of November 2020, paper 32. There they have given 4 position vectors and they're saying that show that AB, line segment AB, is twice of CD. It's not necessarily that they are parallel, just their magnitude has to be written like this. So for finding AB, we should know the vector AB first, which will be the head is at B, so OB minus OA. So OB is 4 minus 1, 1 minus OA is 2, 1, 5, which will be 4 minus 2, 2 minus 1 minus 1, minus 2, 1 minus 5, minus 4. This is vector AB. Now we'll find its magnitude because that's what we want to relate. So square root of 2 square plus minus 2 square plus minus 4 square, that comes out to be 4 plus 4, 8 plus 16, 24, square root 24. If we want to simplify this, we can write it as square root 4 times square root 6, which is 2 square root 6. So according to this relationship, we have to show that the magnitude of CD will be just square root 6. That will be half of this, right? That's why it will become 2 CD. So let's see what is CD. It will be OD minus OC, head minus tail. OD is 3, 2, 3. Alright, OC is 1, 1, 2. And if I subtract 3 minus 1 gives us 2. 2 minus 1, 1. 3 minus 2, 1. Okay. Now the magnitude, which is 2 square plus 1 square plus 1 square. And exactly, it is square root 6. So we've shown that AB is twice CD. Find the angle between directions of AB and CD. Okay, so AB is 2 minus 2 minus 4 and CD is 2, 1, 1. We want to find angle between them, and we know the angle can be found by this scalar product, which is AB dot CD divided by their magnitudes multiplication. Okay, CD. Alright, so let's find the dot product first. AB dot CD will be 2 minus 2 minus 4 dot CD 2, 1, 1, which will be 2 times 2 will be 4, 2 times 1 is 2, and minus 4 times 1 is minus 4. They cancel out, and sorry, this was minus 2, so it will be minus 2 here, not positive 2, minus 2. So minus 2. Alright, now we have everything. We can substitute in this formula. So theta will be cos inverse AB dot CD came out to be minus 2. Magnitude of AB was 2 square root 6 and magnitude of CD was square root 6. 2 and 2 will cancel out. These two square root 6 will give us complete 6. So it becomes minus cos inverse 1 over 6. And the angle comes out to be 99.6 degrees between the two vectors. This is question number 8 of specimen paper of 2020. In this, OABC is a pyramid and they have given position vectors of A, B and C. The edge OC is vertical. That means they are trying to say that this is the Z axis. And similarly, OA is I axis and OB is J axis. Alright. Express vectors ON and CM in terms of I, J and K. Alright. So let's focus on ON first. So how can we reach from O, this is O, to N here. Alright. So simply we can go to C first and then go to Cn. But the problem is that we don't have Cn in terms of I, J or K. So we can do what? We can find CB in terms of ij and k, and because they have written here cn is the midpoint of ab and c, n is the midpoint of bc. That means this part is equal to this, so we can half cb to get cn. All right, so let me find cb here only. Cb will be co plus ob. Yeah, I go from c to o and o to b, and then I get cb. So CO is downwards, all right, and which will be how much is given here? CO, 2 units. So it will be minus 2K. Now from O to B, OB is 4 units and it's positive. So we can write 4J. That's CB. Now we will use this one. So we were finding ON. So O to C first, OC. And then CN. So it will be OC plus CN is half of CB, and CB we just found out in this corner here. So it will be half of minus, rather let's have CB first, then we can substitute its values. CB. Alright, OC is 2K, we know this, 2K. Then CN is half of CB, which is minus 2K plus 4J. And let's simplify everything and we'll get our answer. 2K plus half of minus 2K will be minus K. Half of 4J will be plus 2J. So answer comes out to be K plus 2J. Okay, the second part is to find CM. Okay, and CM can be CO plus OA plus AM. So we know CO, yes, we know OA, but we don't know AM. And for AM also we can find AB. Let's write AB, which will be A to O and then plus OB. That will be AB, right? So AO is this way, and what is it is 2 units again. So it will be minus 2i, and then we can go 4j in this direction. 4j, that is AB. All right. So we can write CM as CO. CO is CO minus 2K. OA is 2i plus half of, we just got it, 2 minus 2i plus 4j. Minus 2i plus 4j. And let's simplify this just like the previous one. Minus 2k plus 2i plus, not plus, minus I, half of minus 2i, and then plus 2j. Alright, so do we have something? Yes, they are simplifying. So it will be I plus 2j minus 2k. In B part, they want to find the angle between ON and CM. So we will use scalar product formula again. Cos inverse ON dot CM over magnitude of ON multiplied by magnitude of CM. Alright, let's find the dot product first. ON dot CM will be K plus, let's write 2J first because J comes first in our component and algebraic form. Dot I plus 2J minus 2K. Alright, so it will be 2J times 2J will be 4, and I has no takers and no I here, so it will be 0, we'll ignore it. K is 1 and this is minus 2, so minus 2, which comes out to be 2. Alright, now the magnitude of ON will be square root. This is 1 and this is 2, so 1 square plus 2 square, that is square root 5. CM, its magnitude will be square root of 1 square plus 2 square plus minus 2 square. So that comes out to be 1 plus 4, 5 plus 4, 9. Square root 9 is 3. Alright. Now let's put everything into the formula. Cos inverse 2 over square root 5, yeah, times 3. If we put this in our calculator, we get 72.7 degrees. In part C, they are saying to find the length of the perpendicular from M to ON. I have drawn ON kind of, not that straight, but yeah. This is perpendicular, right? This is what we need to find. So how about this? Let's name this point P, which is the intersection of PM and ON. And then we'll find the vector PM and we'll find its magnitude, and that magnitude has to be this. So for that we need the coordinates of P, and let's give them coordinates sum A, B and C. Alright, so let's write the equation of ON. So the equation, vector equation of ON. We need a point. Let's use the point origin 0, 0, 0. No need to write it. And then we'll write a parameter and we'll write ON, the vector. So it was k plus 2j. K is the z component, 2j is y component, and there is no x component. So this is the equation of ON. And the point P lies on ON. That means it will satisfy this equation. That means its coordinates are A, it will be equal to 0, B will be equal to 2 alpha, and C will be equal to alpha. We found CM but not OM, so let's find OM. Okay, OM will be OA plus AM. Okay, OA is 2I plus AM. AM is half of AB again, okay, and AB we knew it was minus 2I plus 4j. Alright, so what does OM become? 2I minus I plus 2j. So that comes I plus 2j. Alright, that's OM for us. Alright, now this also becomes the coordinates of M. 1, 2 and 0. We can write it here. 1, 2 and 0. PM will be 1 minus A, yeah, head minus tail. 1 minus A, 2 minus B, and 0 minus C. Alright, and this is the vector which will be perpendicular to ON. So the dot product of this vector we just got, PM, let's write here, PM dot ON has to be equal to 0 because they are perpendicular. So 1 minus A, 2 minus B and 0 minus C dot ON is already known to us, which was 0, 2, 1 will be equal to 0. And now let's multiply 1 minus A to 0, it is 0. 2 minus B times 2 will be 4 minus 2B, and 0 minus C times 1 will be minus C, equal to 0. Now let's substitute B and C with their values in parametric equation here. So we'll write 4 minus 2 times B, which is 2 alpha, minus C, which is alpha, equal to 0. 4 minus 4 alpha minus alpha equal to 0. And that will be 4 equal to 5 alpha. So alpha comes out to be 4 over 5. Yeah? So now the coordinates of P equal to 0. Yeah, that is 0. 2 alpha will be 8 over 5 and alpha will be 4 over 5. And we want the magnitude of PM, which is this. So we'll just put them here. PM will be 1 minus 0, 2 minus 8 over 5, and 0 minus 4 over 5, which comes out to be how much? 1, and this will be 2 over 5. Yeah, 10 minus 2, yeah, minus 4 over 5. And let's find the magnitude of PM, which is the perpendicular distance between ON and point M, equal to square root 1 square plus 2 over 5 square plus minus 4 over 5 square. So it will be 1 plus 4 over 25 plus 16 over 25. That comes out to be 25 plus 4, 29 plus 16, 45 over 25 square root, cancel this 9, 5. Okay, so square root of 9 is 3 over square root 5. To rationalize the denominator, we can multiply by square root 5 over square root 5, and it becomes 3 square root 5 over 5, or 3 over 5 square root 5, whatever format they have given in the question. Let's see, 3 over 5 square root 5, that's what we have just proved.